So now we're going to begin a brief discussion on the intensity of sound. So it turns out something you experience every day is that the further and further you are away from a sound source, the less loudly it appears. And that less loudly we actually describe in physics as intensity. So as you get further and further away from a sound source, it sounds less intense, so a lower intensity. So in the relationship here is that your intensity is related to your power, so of your sound source, divided by area. So in this case, if we kind of envision a sound source emanating sound in every direction, so then it's going to spread out, and as you get farther and farther away, you'll have less and less intensity at any given point at which you are. And what you find out is that the sound is actually being spread out over a larger and larger surface area. In this case, the surface area of a sphere, which is 4 pi r squared. So in that way, in this case, your intensity is equal to the power divided by 4 pi r squared. In another chapter, we'll learn that this also applies to light, like light coming off the sun and stuff like that. So, but the key here is that your intensity is proportional to 1 over r squared. So in this case, if you're twice as far away, you'd have a 4 times lower intensity. So, and so on and so forth. That's the big relationship to learn here. Any discussion on intensity also needs to include a discussion on what's termed the intensity level, measured in decibels. So this is how we commonly measure sound kind of everyday life. One of the local communities here has a noise pollution ordinance, and if your motorcycle, or anything else for that matter, goes over 90 decibels, they can write you a ticket. They have cops that, have little sound meters that measure the decibels coming off your motorcycle and stuff like that. Kind of look at this here. This equation's what governs the intensity level, beta here. So it's equal to 10 log of your intensity over I naught here. And I naught's what's known as the threshold of human hearing. It's the lowest intensity that the average human ear can detect. It's 10 to the negative 12 watts per meter squared. So what if I happen to have a sound intensity hitting my ear that happens to equal 10 to the minus 12? Well, let's kind of see what happens to your intensity level here. We'd have 10 log of... So 10 to the negative 12 over 10 to the negative 12. So and that's 1, and log of 1 is 0, and you end up with an intensity level of 0 decibels. So the lowest, intensity that the human ear can detect rings in at 0 decibels. We'll find out something else interesting here, is that every 10 decibels you go higher is a 10 times greater intensity. So if I go from 0 decibels to 10 decibels, so, and then from 10 decibels up to 20 decibels. So from 0 to 10 is 10 times greater intensity. From 10 to 20 is 10 times greater intensity. And so from 0 to 20 would be 100 times greater intensity, or 10 to the 2 times greater intensity. So every 10 decibels is 10 times greater intensity. If we see how the math works in this case, so we already said that 0 decibels corresponds to an intensity of 10 to the negative 12 watts per meter squared. In this case, 10 decibels would correspond to an intensity of 10 to the negative 11 watts per meter squared. If we plugged that into the equation here, so 10 to the minus 11 over 10 to the minus 12 is 10, and the log of 10 is 1, and so beta would equal 10 times 1, or 10 decibels, and it works out. So the intensity corresponding with 20 decibels happens to be 10 to the negative 10 watts per meter squared. And again, if you plug that into your equation here for I, so you'd end up with 10 to the negative 10 over 10 to the negative 12, which is 100. Log of 100 is 2, and 10 times 2 is 20. That's where you get 20 decibels. So, and if you start making some comparisons here, you'd see that, oh yeah, 10 to the negative 12 going up to 10 to the minus 11, that is 10 times greater. 10 to the minus 11 going up to 10 to the negative 10, again, 10 times greater. And so 10 to the minus 12 going up to 10 to the minus 10 is 100 times greater. So again, every 10 decibels is 10 times greater intensity of sound. So you should definitely understand kind of this basic relationship between intensity and intensity level. So let's take a look at an example calculation involving intensity level. So the question reads here, if the intensity level of a siren is 80 decibels at a distance of 10 meters from a fire truck, what is the intensity level at a distance of 100 meters? So this is a little bit tricky, and it takes advantage of the relationship between intensity and power, so as well as your equation for intensity level. So in this case, one thing we should realize is that, if we take a look at being some sound source here and being 10 meters away versus being 100 meters away. So in the second case of 100 meters away, we are 10 times further away. And we recall that intensity is proportional to 1 over the distance squared. So 10 times further away would actually mean 100 times lower intensity. So 100 times lower intensity. So that's the relationship we can take here. So we could have actually, gone and solved for, some sort of power and stuff like that and intensity and all that. We save ourselves a lot of time if we just understand the relationship here. So 10 times further away, 100 times lower intensity. So in this case, if we're going from 80 decibels to start, if we're 100 times lower intensity, we can take into account our relationships here without actually doing any math. So 10 times lower intensity would be 70 decibels. So, and 100 times lower would be another 10 decibels lower than that at 60 decibels. And that is indeed your answer. So we could have taken our 80 decibels and solved for an intensity here. So, and then taken that intensity and divided it by 100, since we're going to be at 100 times lower, and then plug that new intensity back into our equation to get a new decibels here. But if you understand your relationships here, 100 times lower intensity would be 20 decibels lower than our original, which is why 60 decibels is indeed our answer.